In this video and the next video, I'm going to be talking about these two functionalities in C# called Lambda and Link. And in this video, I will be discussing Lambda in particular. And so in a previous video, I touched on this idea of anonymous data types. And so these are things that we don't need to define the data types. We just use the keyword var for it. And so then we can just sort of define the properties for it as we create it like this. So we use this syntax var, and so in this case I'm using cars as an example. So I'm calling this my car, and then we use the keyword new. Then we put these things in these curly brackets, and so the compiler will know that the color and brand are string types just based on the fact that we have these in the quotation marks here, and that this is an integer type since it is a number without decimal places. And so we can then call these using this syntax right here. So just mycar.color, mycar.brand, mycar.speed. And so I actually have this right here. So this is the code we saw here. So this is just like we saw in the PDF there. Then here I will just be printing these out using that syntax there. So when I do this, we get red, BMW, and 180. This other stuff is just stuff I added. So like putting color here, brand, speed, and the kilometers per hour right there. And so that's where those come from. But this red, BMW, and 180 right here are all part of this anonymous data type here. And so the lambda expressions are what are known as anonymous functions. And so it works kind of the same way where the compiler is just going to sort of pick up on what things are just based on the context. And so what we are going to do, we're going to use this thing called the lambda operator. So it looks like this. It's just an equals and then a greater than sign. And so this is why the sort of order of putting this is important, because if we put this in the other way around, then it just means greater than or equal to. But when we do it like this, it's supposed to kind of look like an arrow, and it reads as goes to. So on the left side of it will be the inputs, and then on the right side of it is the expression or code that works with the entry parameters, which are the inputs, and then returns some result. And so we have something that looks like this. So we can have these expression lambdas that look like this. So we have var square. And so we are essentially this var square here, we are turning into this function here. So this is a function here. So it's taking in some number, and then it's outputting the number times itself. So it's squaring the number. And so I have here, this is the printout. And you'll notice here that I'm using this Unicode here for the superscript 2. And so this is the syntax in which you can use the Unicode here. And this will output a superscript 2, as we will see here in a moment. So we also have these statement lambdas. And so we have var, and so I'm calling this anonymous function result product, and so it's taking in an integer a and an integer b, then it's just multiplying those two things together and then returning the product of it here. So then I have this, which is just printing that out. And so we can look at that in code here. So I will come here, I will uncomment these things out. And so this is just the same code that we saw in the PDF there. And so again, we see this Unicode for the superscript 2. And so if I run this, we get this, and so the output, so I have 5 squared here, so that comes from this 5 and then this Unicode for 2 here. Then I have the equals here in the string, but then I'm doing square with a 5 here, and so it's taking in this 5 like it's a function here, and then outputting the square of it, which is 25. And then here, down here, I'm doing the same thing, but now with 5 and 4. So this is taking in these numbers, so 5 and 4, and outputting the product of them, which is 20. And so that is kind of the two major ways you can think of using, well, there's actually a third major way, which is what I'll be talking about next, for using these lambda, these lambda functions here. And so the next way, and so I'm just going to be using the code for the rest of this, is we can use these as predicates in functions, or in methods rather. And so the next thing I'll do, I will uncomment this out. And so what we're looking at here, so I'm making a list here that has these 7 numbers on it, 8, 6, 7, 5, 3, 0, 9. And then here I'm making another list called even, and I'm setting that equal to this list name, which is test.findAll. So this is a method here, and now I'm putting this lambda right here in as a parameter, or an input into this method here. So we see where I'm using this x here, and this will just sort of be able to, the compiler will know that this x is referring to elements of the list called test here. So it's taking each element of that list called test, and then it's outputting this. So x mod 2 equals 0. So that is true of even numbers. And so what it's doing is putting in this list called even all of the numbers in test that are even numbers. So it's finding all numbers in the even, or in the test list rather, and putting them into this even list. And so it'll make a list of even numbers, which from this list of numbers up here is 8, 6, and 0. Then we also have this one, so I have test.sort. And so this is something that will happen to the test list here. So we're not making a new list, we're just sorting this test list. And so it's just looking at each sort of pair of elements in it and then comparing them to each other. So a dot compare to. So all of this stuff is in the sort here, and so this will list it in ascending order. So it'll become a list of 0, 3, 5, 6, 7, 8, and 9. Then down here I'm just printing those out, and so we can do this. So we still have our code from here up above, but now we have the even numbers, which is 8, 6, and 0, then the sorted numbers, which is the 0, 3, 5, 6, 7, 8, and 9, just as predicted. And so those are some ways that you can use the lambda there. So we can look at a few more of these. So this is just looking at some more of using these like a predicate. So I'm using this array maker here, which is just this up here. So it's just making an array that's populated with random numbers. So 10 to 19 random numbers, where each number is between 0 and 100. And so that's all that's doing. So it's just making this array here. And so this will just print out the numbers in that array in the order that they are randomly put in there. But then we are doing this. We have this var ordered array here. So we are doing array.order by. Then we just do this x with the lambda operator x. Then here I'm using this .to array just to kind of show that you can do that. So this here will be like an anonymous data type, but when I use this .to array, that will make sure to put it into an array. It'll sort of change this anonymous data type into an array here. Then this will just print it out right here. So this is var des array, or des r, so that's just descending array. So we use r dot order by descending, and then this x goes to x here to make a new descending order anonymous data type. So in this one I'm not using the .to array here. And so this will just put it in the descending order type. And so then again, I have this printing it out. Uh, and then here I have this even array. And so this is going to find all, it's going to look in the array here, and then it's going to look for everything that has a mod 2 equals zeros, which are the even numbers. And then this will print it out. And so we can run this here. So we have the lambda unsorted. So this is just the random numbers put in there randomly here. Then this one is sorting them, so we see that this is sorted in ascending order. This one is sorted in descending order, and then this one is just the even numbers. And so this is just the syntax you can use for doing those operations. And you'll notice that these are all things that you could do by just writing a bunch of code. So the nice thing about these lambda, and as we'll see in the next video, the link, is that it's very simplified. So it's something you can do right here in just a single line of code, this ordering, rather than having to write a bunch of code. But the thing is, just because it takes fewer lines of code doesn't mean that it's faster, which is, I'll look at that here in a moment, but we will look at another example right here, so I will uncomment that out. And so here I'm making a list that's populated with these anonymous data types right here. So these are, well, they're not anonymous data types, they're this class of elements here. So that's this up here. So this is the elements class right here. So they have name, symbol, and molar mass right here. So this is just an array filled with these elements classes right here. And so we have this right here. So we have var element list. So we're looking at this element list right here, select. And so we have X here. So it's going to look at each element of that list. And then it's going to put it in this anonymous data type right here. So it's going to put each element of that list into an anonymous data type right there and then print it out. And so we can run this, and it's printing out each of these anonymous data types right here, where it has the name equal hydrogen, symbol equals H, molar mass equals the 1.008 grams per mole, which is what we have going on here. And so we see this just has the name and the molar mass right here, but this is putting it in these anonymous data types that have the name and the symbol and the molar mass with this added grams per mole, the units on it right there. Then this is just printing it out. So yeah, that is some of the functionality you can use with the Lambda. So let's look here at the timer. So I'm going to uncomment some of this out. Well, I'll just uncomment all of it out. So we will uncomment this out here. This I will re-comment out because that's using the link stuff, which I'll talk about in the next video. So we comment that out. So what we have right here, so this is just making an array with this many elements in it. So it's a lot of elements. So that is something like 500 million elements right there. And so this is just putting it into an array here. Then what we're going to do is use this array dot find all with the lambda method right here. We're going to look for all of the even numbers in it. And so it's going to look for the even numbers and put it here and just into this this anonymous data type right here. And then it's going to tell us how much time that took. Down here, we're using just sort of the normal code where we are going to look for all of the even numbers here in our code and then put it into this array this R2 array here, and then we will look at how much time that took. And so we're just comparing, doing the same thing with two different methods here. So up here, we're doing this with a single line of code. So just this lambda right here, this is a single line of code for doing this. We're down here, we are doing it with this many lines of code right here. So this is doing the same thing as that lambda, but with more lines of code. And so if we run this, what we will see is nothing, because I forgot to uncomment it out down here. And so we are going to use the timer method. So I'll uncomment that out. And so now we should get an output for it. So I run that. We see it's taking a little bit of time for that to work. And now we output this out. And so we see that the lambda here took over 3 seconds to do, where the for loop took less than a second to do. And so even though this is fewer lines of code, it actually takes longer for it to do it. And so the point being that just because something looks simpler in code doesn't mean that it's actually faster. So, the compiler is sort of having to do a lot more work here, even though the person writing the code doesn't have to do as much work right here. And so we see that that actually takes more time to do. And so that's, especially when we start getting into, things like algorithms and, trying to reduce the computational time and space that we're using, as we'll talk about in future videos. You really want to take those kinds of things into consideration, and so using this this is not always going to be the best thing to do. So I mean, if you reduce this by a bunch, so if we just reduce this down to like 500, we'll see that this doesn't it doesn't change that much. I mean, it's still sort of several orders of magnitude more time, but the time it takes is so short that it's something you don't really notice that much. And so, like I said, that's just something you want to take into consideration when you're writing your code. But anyway, I don't want to just drone on about this too much. I hope you found this video helpful, and I will see you in the next one.